morning. Today we are going to discuss about Opamps, operational amplifiers. Operational amplifiers are linear devices that have all properties nearly ideal DC amplification. DC amplification in the sense, if you give some voltage at the input side, it will give some other amplified version, that is improved version, increased version of the at the output. That is, if I give 5 volts, I will get some 100 volts or something like that. The main use of op amp is to amplify AC and DC input signals, therefore used extensively for signal conditioning. Conditioning, hope you already know what is conditioning. Changing the properties of a given signal, that is signal conditioning. Filtering, removing noise, unwanted frequencies in the signal, that is filtering. To perform mathematical operations. What are mathematical operations? Addition, subtraction, multiplication, division, integration, differentiation, log, anti-log. All these things are come under mathematical operations. An operational amplifier or op-amp, for short, fundamentally a voltage amplifying device. It will amplify the voltage. Okay. Designed to used for external feedback components such as resistors and capacitors. We will discuss how to connect the external devices like external elements like resistors and capacitors to make it function as a different manner. These feedback components determine the resulting of operation of the amplifier. Okay, by connecting the resistors and capacitors in such a way that it will act accordingly. That is, for example, for an anti-log amplifier, the RC components connecting is in one way, and for a adder the RC components connection is in some other way. Let us discuss later. This is a circuit symbol of op-amp, operational amplifier. An operational amplifier is basically a three-terminal device. So these three terminals are important. Two are inverting and non-inverting terminals. The third one is output terminal. Plus for non-inverting, minus for inverting. Okay, and these V plus V minus denote supply to this op amp. You have to give some supply voltage in order to work this IC, in order to make this IC work. Okay, so we have to give some supply voltage to the operational amplifier in order to make it work. Something like our setup box, we have to give some supply to the DC supply to the setup box, and again we are giving some signal input, that is our cable TV connection, a signal input, and out of the setup box is connected to our TV, something like that. Okay, so here it is something like a small IC. For to make this IC work, we need to give some supply V plus and V minus, so non-inverting inverting terminals output. Okay, and an operational amplifier is basically a three-terminal. One of the input is called inverting input, marked with a negative symbol minus, other with a positive, that is non-inverting input. The third terminal represents output. V plus V minus are separated. The op-amp is a differential amplifier with a very high open loop gain, 25 kilo to 500 kilo. It is much higher than field effect transistor inputs. Higher input impedance means it won't allow any current into these terminals. It won't allow any current into these terminals. It won't allow any current into these terminals. Low output impedance. Its output impedance is approximately 25 to 100 ohms. Okay, and this is the basic ideal operational amplifier, where V1 and V2 are input signals and V0 is the output signal. VD is a difference signal, that is a difference between V2 and V1. So here I1 and I2 are 0, means we already discussed that it is having infinite input impedance, means it won't allow any current to flow into it, and V0 is output impedance. And this is the equivalent circuit diagram. Equivalent circuit diagram means it is not the actual circuit inside this op amp, but it is representing the entire circuit inside this Opamp. That's why it is called equivalent circuit. Okay, so it consists of input resistance, output resistance, AOL, open loop gain, into VD, where VD is this one, difference between V1 and V2. Okay, so if I am giving V2 as a supply voltage to this and V1 as supply voltage to this, V2 minus V1 or V1 minus V2 is said to be a difference voltage, and V0 is output voltage. V0 is AOL times of VD, and these are different IC configurations in Opamp available in the market. One is a dual input plastic type, and this is the IC. This is the pin diagram of this IC. So offset null inputs 1 and 5 are offset null inputs. Inverting, non-inverting inputs, what I have already seen. V plus V minus supply terminals, NC no connection. Coming to this offset null, this is nothing but when we are not giving any input to these input terminals, even though we will get some output at the output terminal, that is known as offset. To null that offset, you have to apply some voltage to these two pins in order to make output voltage 0 when input inverting and non-inverting supply, that is when we are not applying any input to the supply input pins. If we are not applying any input to the input pins, output should be 0. But if we are getting some output means, we should apply some voltage, that is offset voltage, in order to make that output 0. That output is called offset. We have to null that offset, that is known as offset null pins. Okay, by applying some offset voltage, you can nullify the offset. Offset means without input we will get some output voltage. That output voltage is nothing but offset. Okay, and these are the different packages. This is TO5 style the straight leads round type package. Yeah, is having 8 pins. Here also 8 pins, and its structure is like this. More or less all the pins are same. And this is ceramic flat pack and dual inline weld seal pack. Okay, so almost here remaining pins are all no connection. This is the block diagram of operational amplifier Opamp. So coming to block diagram, inside the block diagram we have 3 stages. One is differential amplifier stage, level shifting stage, output stage. Inside the differential amplifier stage again we have 2 stages. One is input stage, other one is intermediate stage. In input stage, it's a dual input balanced output differential amplifier. We will discuss later what is this dual input balanced output. These two amplifiers are very similar. We are connecting these two amplifiers back to back in order to improve the gain. We will discuss how to improve the gain in next slides. And level shifter stage. This is the emitter follower using constant current source. Okay. And output stage. This is the complementary symmetry push-pull amplifier. We will discuss one by one what are the purposes, what are the advantages of these stages, and why to connect these two similar amplifiers in back to back. So these are the supply terminals, this is the output terminal. See, this is a schematic diagram of operational amplifier. Operational amplifier can be designed with transistors, FETs, field effect transistors, MOSFETs, so on and so forth. Okay, so this is the transistor configuration. Here this is the input stage, this is the intermediate stage. So here this is input stage, this is intermediate stage. These two are shown here. This intermediate input stage, level transistor stage, output stage. So this is the input stage. Input stage we have two inputs, non-inverting and inverting inputs, and the outputs are given to the next similar stage. Okay, so these two stages are more or less similar. Okay, and here it is a feedback like this. Okay, and this is what we said, emitter follower stage. Okay, so here is the emitter follower stage, and this is the complementary push pull amplifier. So this configuration is called push